when we talking about the challenges, if you will, in the quality industry, probably it will not be a surprise. Something is, oh, now it's working. And when we talk about quality activities, whatever we have, and you see all those components that kind of popping up on the screen, and I, of course, can read them one by one, but you can read them as well. It's about 2D ballooning, 3D model, ballooning, managing job and lots, tool engagement, event inspection procedure, in process inspection, non-conformance, CMM data, shop floor, and you probably believe me that I can fill up another 2-3 screens with all those function or requirement or activities. But the question is how we manage them today. And there are either multiple systems to handle the entire inspection and quality processes. But at the end of the day, when you look, it ended up mainly in Excel, and then ERP, and then Excel, and then ERP. And we are kind of getting lost. So looking again into the shop floor, and you know that there are tens of thousands of inspection tools type, tens of thousands of measurement tools, from manual to Bluetooth, wireless, CMM, vision, arm, laser, and the list is long, and it is growing daily. I think the biggest question is not about measuring only the part right out, it's about where is the data goes. Either it's written on piece of paper or type into Excel or click by Bluetooth device or by CMM vision on our machine. There are hundreds of inspection tools that we use and from start to finish, but the question is what we are doing with this data. Now, if we get into another example, for instance, APQP, and I'm sure that you are familiar with it, most of you, if not all of you, but just to give you an idea, talking about the advanced product quality planning, or under it, you can see, you talk about the PPAP or FMEA. Then if you look in what the requirements are, and the list is long, talking about PPAP package elements, you can see the design record, authorized engineering change management, customer engineering approval, design FMEA. Well, I mean, I can read them, but you can read them and you know them because you have a lot of experience on that. But the question is how we manage it. Where is the data? How it's connected to those that we collected or gonna collect on the shop floor? How it's connected to the SPC data. So APQP, I would say, to be very, cautious in my statement, 90 plus, if not 99% Excel. So, I mean, you look into more than 95% of the industry, their APQP is Excel with tons of tabs. So it's Excel, and the problem is this data, what we're gonna do with it. Now, you see this guy probably, and I can quote one of our customers who is an OEM, large OEM in the aerospace, and this is what he shared with us. I have a lot of data, but I do not have information. My data is spread all over the place in endless softwares, folders, as well as hard copies in boxes, reports, plans, in process inspection, results, SPC, engineering change, you name it, I have it. But what conclusion I can get of all this data? I'm quoting, guys, he said nothing. My hope is that no customer will come and complain, and then I'm going to spend 2 weeks to find out all the information. So, you know, this guy, and this is what our guys actually stated. I'm hitting my heads on the wall when I need data. So I have a lot of data, but actually I have zero information when I need it. So talking about all-in-one, and this is kind of the concept of inspection manager of IQA. If you look into this chart, there are 3 components when we talk about quality management system. I call it the downstream preparation, which automated downstream process when you take 2D and 3D, and all the way through data collection and reporting. It covers all aspects of quality. And that's you can do when you have database driven application and you have all those pieces and components together and integrated. If we are looking kind of on a much more details into it, and we look into inspection manager, you see the infrastructure. First of all, the centralized database. Then we have what we call the external application integration, which is known as an API, application programming interface, so we can integrate with any legacy or enterprise system like ERP, PLM, and others. Then there is a layer of security. When you work with enterprises like Lockheed Martin, BAE, and others, security and access control based on project, based on user, based on location is super critical. Then
Sam, we lost your audio again.
somebody told me that you cannot hear me, and can you hear me now?
Yep, we hear you now.
For how long did you lose me?
Just why don't you go back to just the beginning of this slide and review it again?
All right, sorry guys. Okay, so talking about our infrastructure all in one, how it looks, then it starts with centralized database, and then we have the API, which is application programming interface, where inspection manager can integrate with any enterprise system like ERP. And this is not just getting data from ERP, we send data to ERP, so it's dual or both directional communication. We have a very high level and very detailed security, working with large enterprise like BAE, Lockheed Martin, and others. You need to enable this kind of security, segregation between project, people, groups, location, etc. Then comes the data source, which is 2D drawing or 3D model, and 3D model or model-based inspection or definition. It's a whole topic by itself, which we covered very well. And then comes the layer of functionality, which I talked about it earlier when you see all those pop-ups on the screen, what we need to handle from A to Z, and why we are using mainly Excel and sometimes other system, and then they are not integrated. So on top of this, we have the internal and external or supply chain quality requirement assignment. Then we have the data collection, and data collection can be collected from your shop floor or from suppliers directly to the database. And of course, after that comes the reporting. So all of this is encapsulated to a kind of a one system. And if I will summarize my quick opening here and let Chris share with you like real time or real life what he's doing, what we are doing. This is not about generating data. It's about quality and trusted data. It is about integrated and synchronized and analyze the data from multiple resources and tools. So yes, it is not about the data, of course. It's about valuable information that you can use to make decision to improve not only the quality process, but the entire manufacturing process. This is where I think quality management department can kind of move away from go, no go department to something that really provides value to the entire process in the company. So Chris, please.
Yep. Thanks, Sam. All right, let me know when you can see my screen.
We can see your screen.
Okay, very good. All right, so I wanted to go through and show a couple of just tangibles for how we end up providing an all-in-one solution. So real quick, just to kind of recap in a slightly different way, I'm going to just show kind of the topics of what we're talking about. So I think Sam called it quality planning, data collection, and reporting and analytics. So same concept here of quality planning, inspection, and then reporting and analytics, right? So in the quality planning side, we've got some high level concepts that we're talking about. And this is kind of like a staged process here of I bring in my print, I auto balloon it, I assign measurement tool categories, I may break it up into manufacturing operations and key dimensions or assign key dimensions. And I'll need to assign some jobs and lots, kind of set up that infrastructure, do my AQL and criticality designation. And that kind of goes hand in hand with the sample planning. And then we release this to the shop floor, right? Next phase would be from the shop floor or your inspection room. You have first and last piece inspections, in process, final inspection. And that can be manual. It can be done through digital gauges like calipers and measurement equipment and such. It can also be done through automated inspection equipment like CMM's vision systems and such. A huge power here that we're applying, and you'll see this in just a minute. We'll cover this through kind of a demo. But having an integrated NCR tool allows us to take NCRs from kind of the end of the process to right at the point of a failure being identified in an inspection. And so you're actually bringing that notice and the alert and such right to the incident for faster response. And last section here, we're talking about reports and analytics from SBC, various FAI, PPAP, NCR reports, and measurement tool usage. Okay, so those are the kind of fine points, if you will, or the high level points. Let's go into the product and show how some of this works. So this is Inspection Manager. For those of you seeing this for the first time, and at the very beginning, there's what I mentioned as the auto ballooning phase. It's important to realize that this is a database-driven solution. So when we run something like auto ballooning here, and we go for the current page, we can do auto balloon, multi-page prints, and we have some options here for different types of dimensions that we may want to ignore, but we'll let it run and balloon the whole thing. So this is kind of the core, the starting point of establishing your measurement criteria that you're going to inspect, and it enables the entire rest of the process all the way downstream. And so when we talk about auto ballooning, we're talking about it in two phases. There's recognition and interpretation. So we're recognizing where the dimensions are on the print, adding a balloon to them with a unique identifier. And then we're also interpreting the requirements, everything from kind of like your basics, your linears, diameters, and your GD&T requirements. All of that's being captured and interpreted to a high level of accuracy by the system here. Okay, so that's opening up. And so again, it's important to realize that this is all database driven at the back end. So it's not something that we're just taking little screenshots of and doing some algorithms there. This is something that's being ingested as real data. Okay, and so you can see that it went through and captured some of these. I'm going to apologize for it not capturing everything. There must be a quirk here. We're working with a developer preview just so we can show you some of the latest things. And so we're currently testing for OCR regression, but that's okay. In main releases, this captures everything that you would see on the screen. And so you can see what it's doing, that it's applying the balloons to the dimensions and capturing the characteristics, but it's not just that recognition, it's also the full interpretation as well. So you can see our full bill of characteristics here. If we open that up, right? And so you can see each dim number and the requirements here, nominal upper and lower tolerancing that got extracted, pulled from our tolerance tables that you can define, and you can do that on a per customer basis and such. Okay. And so there's some process here in flow, but I want to kind of give you high level because there's a lot of information to cover with an all-in-one system. So we mentioned measurement tool categories. So over here we have gauge categories. So as we scroll down, you'll see that some dimensions were assigned a gauge category automatically. And so that's part of the intelligence in the system. I don't have that fully set up for every dimension, but I just want to show you for a few that what I have is diameters can get auto assigned for coordinate measurement machine, like so. And so we can do auto assignment based on the dim type, or you can manually assign gauge categories. All right. Next, from that, we have the manufacturing side of things. So when you're planning out your inspections, this bill of characteristics that we have in the bottom here is really just the list of all of our inspection criteria, right? But in reality, I actually inspect that in phases according to my routing steps. And so we would use what we have here is manufacturing operations. And I would be able to just graphically pick certain features that get checked at any phase of the process and break them up into manufacturing operations. And so I can grab specific features here, I'm kind of arbitrarily picking like so, and I can build out operations that get checked. So this way I'm prepping for the shop floor to be able to kind of pre-package a specific or a unique inspection plan for my inspectors on the shop floor, because at each stage of the process, they don't need to check everything. They just want to check, or they just want to see a list of specific features that they need to pay attention to at that time. Okay, so this provides a pretty huge amount of flexibility here. And so these individual dimensions can even be modified for their requirements, because maybe you have in-process checks that are pre-finished, so they don't match the finished print. They have a little bit of extra stock, or maybe you are machining undersized to allow for a plating operation to take place, and so you need to check a little bit undersized from the finished print. So all of that can be handled within the context of these manufacturing operations. Okay, they can all have unique inspection frequencies assigned and methods of inspection, etc. So that's all there and able to be handled. So something new that just came out is the ability to assign manufacturing key dimensions as well. And so if I have the concept here is I have a key feature that is grouped with several other features that are all cut by the same cutting tool. Okay, and so I want to identify the key feature out of that group that I'm going to inspect, and maybe that's the one with the lowest tolerance or tightest tolerance or something. And then the rest of the dimensions I can assume are good based off of that key feature. And so we're able to actually assign key features like so, and apply groups accordingly like this, and then say other features in here I can just group into that key feature set. Okay, and you'll see that the key is actually got a double balloon on it, or a double shape on there, so that I can identify it right on the ballooned print. Okay, so a huge amount of functionality there just to be able to do that. There's some other things we're doing kind of on the outset from that, but there's only so much time to show things, so we'll leave it at that. Okay, so the next concept here that I mentioned is kind of the job lot management, right? So again, when we're prepping for the shop floor inspections, it's done within the context of a job and a lot. And so up here, we've got our jobs, and I can add a new job into here, all right? So I'll just give it a job number. We'll give it a quantity. We'll say there's going to be 100 pieces that we are manufacturing here. And then for a status, we start off in planning, so that way I can kind of do all of my preparation, build my samples in, which we'll talk about in a second. And then once I switch it to active, it's visible on the shop floor. Okay, so there's kind of some phasing that gets introduced there. Okay, something important, I'll kind of hit on this a little more later, but notice that we can enable notifications for the job to monitor it for any dimensions that are inspected where you get a failed result. So I can automatically send alerts out based on those failed results at a job level. Okay, so we'll keep that in mind for later. We'll touch on that a little more. So I'm going to save this, and you'll see what it does. that I now have one job in here, and I can have, you know, a whole series of jobs. I may have multiple active jobs, or I may have jobs that have been completed in the past, so they're archived. So we have tools for managing all of that. And then I have a lot right here as well. So there's always one lot. Now within, I can always have multiple lots if I manufacture in multiple lots, but not everybody does that. So at the very least, I have one. Now within the context of that lot, I'm able to actually build my sample planning. Okay, so there's some details here, but we'll just give the high level of, I can pick my AQL table that I'm working with. All right, I can pick the inspection level that I need to inspect to, and as a combination of my lot size and the inspection level in the AQL table I've picked, when I hit save, that assigns a particular sample size that needs to be inspected for that lot. Okay, so I'm able to just pick that up very quickly. Okay, and then I have a default quality level as well. So let's kind of dig into this a little bit. So this, at the moment, we're kind of driving sampling at the global lot level, right? And I can create my lot samples that way. But to take it a step further, in reality, what happens is I end up assigning designators to testing. Yep. Can you guys hear me still?
Yeah, you're back.
All right, I should be back now. All right, so so I can assign designators to individual dimensions because some dimensions are critical, some of them are majors or minors, and then there's AQL levels associated with each of those designations, right? So I can take a few dimensions here, do a bulk update, and say that these are going to be critically inspected features. All right, so I can apply that, close. And you'll see what happens here, that as those are assigned as critical features, now I have, they're set to 0 AQL, so 0 acceptance level, right? And so the same thing could apply for majors and minors. So you can set up your sampling rules in coordination with your designators, so that's automatically attributed to each of your dimensions. Okay, so now when I go up to my lot level and I start planning here, I can create lot samples. Okay, so it's automatically creating the 20 samples for me. I can add a first and a last full inspection. So these 20 samples are just going to include the dimensions that need to be inspected at the production level, because I've already set up which dimensions are critical, major, minor, and need to be inspected in process. Okay, and then I have my first and last full that I can apply if that's something that I want to include, right? So here we'll include both of them in this case, and we'll say okay and let that process. And you can see what it does here. So super quickly, I'm able to just generate all of my samples. So here's my first piece that gets built with total result capacity. So it includes all dimensions that need to be checked on that part, because I'm doing my first piece inspection. And once that's verified, I can move forward and inspect all of the incremental pieces. And so this is checking every 5th piece because it's 20 samples that got generated per my AQL level. And so it's 1, 6, 11, 16, etc. through here. And these only include the features that need to be checked based on the criticality that we assigned down here. Okay, so it's automatically kind of rolling all of that, those formulas and calculations up. And then there's the LAI with another full feature inspection. Okay, so there's some variability here too. There's options. I'm kind of showing just the most generic way of approaching this, just so you kind of have the high level concept of what's being applied here. Okay, so the next stage, right, is I've done my sample planning. I've got my my designators all set up, my inspection methods. Now I need to shift over to the shop floor to actually perform my inspections and pull all that up. So now that we've prepped all this stuff, I can easily go to my shop floor applications. Actually, here, I forgot something. We're going to need to shift this job into an active state so I can pull it up. Okay, and we'll do that for the lot as well, because the lot is also active. Okay. So now that I've done that, I'll go into my shop floor side. So Inspection Manager, what we've just been talking about, is kind of our quality planning engineering tool, but this is a slimmed down pure inspection or data collection interface that's built for shop floor or inspection room use. And it's primarily built for manual inspection entry. And so we're inspecting some features with manual gauges or digital calipers or gauges and so on. Or maybe we just like key in like pass fail results for some things. So the idea is I would log in with my user here. We'll log in. And because I've got a traveler sitting in front of me, I can just do a global search for that job number that we had. And I forget what it was that I put in there. The 3164 for that job number. All right, so I'll search for that. I'll hit find, and that pulls that right up. Okay, so when I click on that, you can see what I've got from this shop floor view now. I can pull up all of my samples that were prepped for me. I can see how many DIMs get checked per sample here, okay? And then I can go forward and perform my inspection. So I'm able to see some KPIs about each one, the percent completion and such. If I'm working across multiple lots, I can filter that way. And there's different types of inspections I may want to perform. I may want to inspect one piece all the way through. That's true of a lot of my production pieces. But if I had set this up to do a final inspection as well, where I'm doing an AQL sampling from a group of completed parts, then I can also do a multi-serial number inspection. Okay, and so I can grab like 10, 20 random pieces from my lot, and then I inspect one feature at a time across all of them, and then I move to the next feature and inspect it across all of them, etc. So a few different modes of operation here, but the concept is once I click into one of my samples like so, you can see I've got, now for some context here, this is the equivalent of what most companies are used to in the form of like an Excel spreadsheet and a ballooned PDF, right? So you use those two documents, they're bundled in with your job travelers. So you pull out that Excel spreadsheet and you pencil in, or maybe it's digital, it's on a computer, and you type in your inspection results. But this is all of that kind of combined into one interface that's directly pulled from our centralized database down to the shop floor. And it's kind of packaged in such a way where I can filter into specific operations, right? So I can look at my op 10 dimensions and it filters out everything dynamically, right? And so I've got just the dimensions that I care about at this operation to inspect for this first piece, okay? And it'll show me that on the ballooned PDF here as well. You can see it filtered out all the other dimensions that should be checked and just shows me those balloons. Okay, so all I have to do here as an end user or as an inspector is input my results like so. So I'll put something in, it passes and it bumps me to the next dimension. Obviously we're flying a little fast here. I'm working on a live part. I didn't prep this, so there's some adjustment that you would have done with like moving the balloons out of the way and such for kind of cleaning things up. But hopefully you guys will forgive some of that since this is, we wanted to show this live just to show how streamlined the general process is here, right? And so I can put in some other results here as well. I can even, based on dim sets, I can see things like just show me the manually inspected results versus show me the CMM inspected dimensions, and I can kind of break things up further that way. We didn't quite get into that, but let's say I put in a result here that is going to fail. Okay, so this is going to fail the requirement here. So I'll hit accept. And you'll see what happens. It alerts me that, hey, this has failed. You may want to do something about that. So maybe I look over here and I realize I made a typo, or perhaps I don't have confidence in the measurement. And so I want to go back. I want to take another reading and make sure it's consistent. And so at some point, though, I may say, okay, keep that failed. So I'll say keep failed. And it's going to trigger a non-conformance. And hold on 2 seconds. So this is, all right, so I had this configured for the last generation non-conformance that we had, but let me pull something real quick here because this is worth seeing. here. Okay. We had 2 generations of nonconformances that we recently did an upgrade for. And I'm going to set that up here. Okay. All right, so we're gonna reset this. Okay. So we'll reset this and put in the result so that this will trigger the appropriate nonconformance workflow. We'll say keep failed. Nope, and it didn't reset. There we go. All right, this is what you get for live demos. And we'll go to this one here and we'll put in something that we know is going to fail, accept. All right, so it's not resyncing. So, but the concept here though is, and so I can't show you the advanced nonconformance utility, but the value here is having NCRs directly from the shop floor is a hugely powerful tool, right? Because typically we would identify a non-conforming feature and that would have to get carried over, and there's some paperwork that gets done by another party or person or role, and then that reporting kind of rolls up at the end of the process. And so there's delays to the decision-making capacity of your teams because nonconformances are delayed in getting generated. And so in that, because we're able to bring nonconformances directly down to the shop floor at the in-process stage, not just final, but also in process, we're able to trigger response and action to the nonconformances and the failed results that much faster. Okay. So that's how that would be set up and triggered. All right. So lastly, let's kind of tie this back now and show that as we're inspecting results here or dimensions and we're applying the results, I want to emphasize that, again, this is a single database that we're sending all of these results into. And so that's getting aggregated to a top level. Okay. So when we go back to the inspection manager side here and we open that up, so when we go back to Inspection Manager and we start looking at those samples that we inspected on the shop floor, you'll see this FAI piece that we were inspecting right here. And why is it not? All right, well, you guys are gonna have to forgive a lot today. There's some behavioral issues here going on. So yeah, forgive me for that. But let's say that these were put in place here, right? And we had measurements that were collected like so. These would populate on here as live results like this. So just like this. So I'm putting it in through a different method here. This is something that we could do through like a final inspection if certain inspectors had access to the inspection manager interface. There's flexible options for how to enter results, but the results populate here on the form, just like so. So I'm able to kind of see those aggregated here in that single interface. Okay. And then when I'm looking at my samples view here, I'm able to see kind of a roll up of all of my samples, right? And their inspection status. So I can see if there's results or dimensions remaining that need to be inspected, right? I can see failed results that were identified throughout the lot. Okay, so that way I know if there's non-conformances that I need to build, generate, or any kind of corrective actions that I need to put together, or if I need to disposition these pieces as good or scrapped. Okay, so all of that's able to be managed through this one interface here. Okay, so then from that, there's the next level of I want to generate some SBC trends. I want to monitor my lot inspections for SBC results. So that's as simple as right here. So that's as simple as this, just saying I want to collect SPC here. And so I can turn on SPC monitoring for specific results. So that way, the dimensions that I care about that are critical, I can watch those in my SPC charts and such. Okay, because again, we're collecting all of that data to one place, it's already being taken care of. And so just by turning these on, I'm able to see all of that data generated. Okay, and then from that, once I have all of my results collected in, I'm able to, let's go here. So once I have that and I have all my results collected, I'll show you just, we can put in some sample data here that's going to have some results in it. Like so. So let's say we've got our samples fully inspected at this point. So there's no remaining dimensions to be inspected there. And so if I look at any of those samples like this, I can see those results populated here like so, and then I'm ready for the reporting side of this. Okay. So I can go in, I can do single piece reports, I can do multi-piece reports like so. And so let's look at the single piece. I can pick the dimension or the sample that I want to report on. So maybe that's an FAI piece right here. And I have a report template that I can choose from. It's important to understand that we have a huge amount of flexibility in our reporting and the templates that we build. We have a full report designer where we can build custom dimensional based reports. We can even take your Excel reports or templates that you're used to working with. And if you like that, you want to keep it, we can actually import those into the system and use that as a template going forward. That's custom for you. And so we can hit create report like so. And you'll see here that I get my full form 1, I get form 2, and I have form 3. And so I get all of my results populated nicely into that end form, just like so. Okay. And so there's, as I mentioned, a wide level of flexibility within the reporting that I can do. And so this can be an FAI report. This may be a PPAP report. As Sam mentioned, we have a full APQP module, which we don't have time to get into today. That's probably for another webinar. But all of that is triggered off of that source data that we're building from the ground up, from the ballooned print to the inspection planning to the shop floor data collection, all the way through SBC analytics and reporting. And all that's able to be done through that one platform. So with that, I'll hand it back to Sam, and thanks for bearing with me through the couple of little hiccups. But
thank you, Chris.
Yeah.
Can you hear me well, guys?
Yes, we can.
Okay, great. Yeah, some hiccups. That's why we said never use the beta version on alpha version, but that's okay. I think with that, Jack, I would like to open if we have any question from the audience that we need to address. We'll be glad to do. Are there any questions that we have, Jack?
Okay, I see no questions at this time.
Good. So it all was clear. Great.
So yeah, so I think that's the case.
Perfect. So I think that we would like to thank everybody that joined today. I hope we could, convey the message of all-in-one, and I'll move it back to Jack.
Yep. And like Sam indicated, thank you for attending today. If you need more information, there are multiple ways to get a hold of us. One is by phone, 888-727-1266, by email to info@highqa.com, or visiting our website, where there are some, there's a contact form and a request a demo form there, schedule a demo, at highqa.com. You will receive a link to the recording today's session tomorrow, and we appreciate your taking the time to be with us today. And any questions that may come up after the session, feel free to get in touch with us, and we're more than happy to answer them at that time. Thank you for attending.
Thank you.
Thank you, everyone.